Hello, my name is Scott Heinlein, and I am part of the Dell Technologies Telecom Systems business. Our focus is helping communication service providers, or CSPs, transition to 5G era by providing open, standards-based solutions and working with our ecosystem of partners to bring to market complete end-to-end solutions. I plan to walk through why we need to transition to open technologies, the benefits of doing so, differences between proprietary and closed systems, and what some of the challenges are, and then discuss at a high level how Dell Technologies is working with TIP, specifically TIP LATAM. Proprietary and closed systems lock CSPs into specific vendors. This results in a lack of control for CSPs as they are dependent on the proprietary vendor for new features and innovation. Today, primarily due to proprietary RAN interfaces, there are only a handful of RAN vendors that supply the majority of RAN technology to the CSP community. This results in the CSP community to be extremely reliant on those handful of vendors. Opening up and standardizing the RAN interfaces opens the doors to new vendors and therefore new innovation. We have already seen new entrants in the RAN space, including Dell Technology partners such as Mavenir, AlcioStar, CommScope Ruckus, and many others. These new vendors are breaking the proprietary stranglehold and offering new innovation and ways to build out the next generation of the RAN to support 5G and 5G services. Lastly, open technology offers CSPs with new options to create differentiated services. This will become even more important as we transition to 5G and the new enterprise services that will enable. Today, proprietary technology and lack of control makes it extremely difficult for CSPs to differentiate their services from their competition. Open technology will change this and spur new innovative services with the opportunity to differentiate. From a benefit perspective, there are many benefits to open networks, including the increased flexibility of vendors and deployment models. This provides operators with choice of who they want to deploy and where they want to deploy them. It gives them a lot of flexibility versus being tied to just one or two solution providers. Also, service differentiation, as I mentioned previously. Operators are really striving for new ways that they can make their services more unique and differentiated. Having the flexibility of multiple RAN providers and the different deployment models gives them an opening and a lot of flexibility to help create and deploy new differentiated services. In addition, there's a promise of lower TCO with OpenRAN or open networks. And while there are many factors that determine the overall TCO savings, including the performance of the solution, the deployment scenarios, how you manage the deployment, and many others, it is expected that over time, open networks will ultimately provide lower TCO versus the proprietary systems that are out there today. Also, there's a need and a criticalness of securing the telecom supply chain. So security in the mobile network, as we know, is a critical imperative. And OpenRAN and open networking is really a key enabler to making this happen. And then the last thing from a benefit perspective that I'll talk about is operator control. OpenRAN, because of its openness, gives the operators really full control and their ability to control their RAN, since they have many, many more options and many choices for who they want to use from a vendor perspective. Today's proprietary closed systems include the proprietary interfaces between the radio units or the RUs and the broadband base units or the BBU, and also from the BBU to the 5G core. These proprietary interfaces are what creates the quote unquote closed system. And these interfaces are unique to the vendor supplying the specific solution and is therefore what really results in locking in to that specific vendor. Open models leverage standard-based interfaces in replacement of the proprietary interfaces. The OpenRAN architecture is typically disaggregated, where the BBU function is disaggregated or split between the distributed unit or the DU and the centralized unit or the CU. The CU can also be further split between the control plane and the user plane in some instances, and this provides further flexibility as far as how they can be deployed. Now, leveraging standards-based interfaces opens the door for multiple vendors to leverage these interfaces to innovate. Also, if a vendor isn't meeting a CSP expectation, the CSP can more easily look to replace that vendor with another open-based vendor. This creates competition and results in more vendors and ultimately innovation. One thing to note is that disaggregation does not equal open. Some vendors have disaggregated their solution, but they still maintain proprietary interfaces. And thus, they have a disaggregated, but still a closed system. This is an important and a common misconception kind of in the industry, as people tend to think of open and disaggregated as being the same. So they exchange those two terms. Now, from a challenge perspective, and along with the benefits of open network, there's also some challenges that the industry is going to need to resolve over time as we continue this transformation to open networks. First and foremost is the challenge of integrating a multi-vendor solution. OpenRAN adds an extra layer of complexity with this, as integrating more vendors using less proven technologies will take longer to achieve. Smaller operators might be hesitant to take on this challenge at the early stages, as they tend to have more limited resources than the larger CSPs. And also things like network slicing will even complicate this integration even further. Also, most open software vendors lack integration and support services. Most of these vendors are startups and simply do not have the resources required to support mobile operator deployments. This is creating a gap, since traditionally the large network equipment providers who provide the RAN solution also provided support and integration. And then another challenge that needs to be overcome is the performance gap between purpose-built solutions, so the proprietary solutions, and the new open solutions. For example, currently the performance of many OpenRAN solutions may not match the performance of the current proprietary-based RAN solutions. The proprietary solutions are optimized for the RAN function and include a very tightly integrated hardware and software components. However, obviously this does come at a premium, since operators are then reliant on the proprietary vendors for feature upgrades and all the aspects of the solution that we've been talking about. So it's imperative that in the OpenRAN case, the OpenRAN solution must be on a trajectory of being equivalent or even higher performance than the proprietary-based solutions of today. And there are great advancements happening in this area currently. The OpenRAN performance and reliability requirements are quite extensive. So the underlying infrastructure is really critical for successful deployments. Dell Technologies recently introduced some new server platforms that are based on the third generation Intel Xeon chips
These servers, the Dell technologies are the Dell EMC PowerEdge XR11, XR12. We also introduced the R650 and R750, are designed for telecom OpenRAN solutions. The PowerEdge XR11, XR12 are 1U and 2U in height and 10-inch in width. Their 400 millimeter short depth and NEBS 3 compliance are great fit in tight spaces and has some environmental challenges. And in addition, the Dell EMC PowerEdge R650, R750 servers are a great choice when there's no space limitations or environmental challenges. And many of these products are now part of the TIP community, as we are collaborating with TIP to enable community lab environments. Some of the ways in which Dell Technologies and TIP are collaborating include, we are designing and delivering solutions that meet and exceed the requirements of edge deployments. We have a focus on optimizing the edge computing environments that integrate a wide range of acceleration options. We are also working on Ethernet switching solutions that meet the tight timing requirements of 5G networks. And we have remote virtualized compute platforms for connecting remote locations. And Dell has contributed compute infrastructure to multiple TIP community labs, including the Facebook lab in the US and the Intel lab in Brazil. Dell is working with the TIP community labs to create a foundation for OpenRAN related development, testing, and verification. Dell continues its engagement with the TIP labs, providing services to optimize configurations, continuing troubleshooting, and technical support. Dell continues to remain engaged in the TIP community labs and is exploring additional opportunities to enable and enhance these supported environments. So to summarize, Dell's goal is to help simplify and accelerate the OpenRAN open network transition. Our collaboration with TIP Latam is a great example of how we were coming together with other industry leaders to accelerate the development and deployment of open, disaggregated, and standards-based technology solutions that deliver the high quality connectivity that the world needs. Thank you very much, and feel free to contact me at the email address shown on this slide for additional information. Thank you and have a great day.